Row number 3508. Implement router. So let's read the problem statement. We have to design a data structure that can efficiently manage data packets in a network router, right? Each data packet consists of the following attributes. One is source, a unique identifier for the machine that generated the packet. And we have destination, a unique identifier for the target machine, and timestamp. Timestamp is nothing but the time at which the packet arrived at the router, right? And here one more thing, if you see this line, note that the queries for add packet will be made in increasing order of timestamp. So whatever the queries that we are going to get, they will be in increasing order of timestamp, right? So just make a note of this point. So what we have to do, we have to implement the router class, right? So router int memory limit, right? So this is going to initialize the router object with a fixed memory limit, and memory limit is the maximum number of packets the router can store at any given time, right? So this is given to us, and if adding a new packet would exceed this limit, the oldest packet must be removed to free up the space, the oldest packet, right? So this is nothing but, I can say, first in first out, right? So whatever the element that you are going to add first, that is going to become the oldest one, right? And if the limit is full, then you are going to just remove the first one, the first element that you have inserted, right? So this is nothing but FIFO, right? So if adding a new packet would exceed this limit, the oldest packet must be removed to free up space, right? The element which is inserted first is going to be the first one to move out, right? And here this method, if you see, bool add packet, boolean add packet. So in this we have source, destination, and timestamp, right? So it is going to add a packet with the given attributes to the router, right? And a packet is considered a duplicate if another packet with the same source, same destination, and same timestamp already exists in the router, right? So here if you see this particular example, so if I have this router, right, something like this, source, destination, and timestamp. So later on, see 2590. So here see 90, 90, 90, 95, 105, 110, 110, like this. So if you see, the timestamps are in increasing order, right? This is one thing. But here if you see, if you have this 1490, and again you are adding same thing, same source, same destination, and same timestamp here for this and for this one, then it is bad, right? So that simply means that it is nothing but a duplicate one, right? So here a packet is considered a duplicate if another packet with the same source, destination, and timestamp already exists in the router, right? And we have to return true if the packet is successfully added, that is, it is not a duplicate. Otherwise we have to return false, right? So now see this method, int and forward packet, right? So that simply means this one, right? So here it is going to forward the next packet in first out order, right? So what this method is going to do, it is going to remove the packet from the storage, right? First in first out, okay, in this manner. Then we have to turn the packet as an array, the packet that we have removed, source, destination, and timestamp. So these three values we have to return, right, in array form. And if there are no packets to forward, then in that case we have to just return an empty array. So this is the functionality of this one. Now if you see this method, int get count, right? So in this we have destination came to us, right? This second part, right? Destination, right? And we have start time and end time, right? So what we have to do here, we have to return the number of packets currently stored in the router not yet forwarded, right, that have the specified destination and have timestamps in the inclusive range, start time to end time, right? So this is the functionality of this get count, right? So number of packets currently stored in the router, right, this destination, right, that have this specified destination and have timestamps in this range, right? So here if you see example number 1, so we have router, right, and here 3. What does this 3 mean, right? So here if you see, this is nothing but memory limit, right? So router and 3 means memory limit. So router is equal to new router 3. So it is going to initialize the router with memory limit of 3. Done, right? Then we have add packet, right? So we are going to add this packet 1490. Then again add packet, we are going to add this. Then again add packet, we are going to add this or not. No, first I need to check in this add packet method. I need to check there's one duplicate, right? So I can say 1490 is already there, right? So again 1490, no. So here I'm able to add this 1490, I have to return true. I'm able to add this 2590, I have to return true. But this 1490 I can't add, right? Because it is already there, so I'm returning false. Can we add this packet 3595? Yes, we can. We have added this, we have added this, we didn't add this one, right? We have added this, right? So total 3 right now. At most we can fill 3, right? This is the limit, right? This is done. Now next time I want to add this packet, right? That is nothing but this 45105. So to add this, right, since limit is 3, so I have to remove this one, then 1490, right? So here if you see 1490, packet is added, return true. 2590, packet is added, return true. 1490, this is duplicate packet, returns false. This 3595, packet is added, return true. Now when I'm going to add this 45105, right, so I have to add this packet, right? Packet is added, but we have to remove this 1490 is removed as number of packets exceeds memory limit, which is nothing but 3. Okay, and then I have to return true, right? First I have to remove this, and then I have to add that, and we have to return true. That's it. Now after that, if you see next is nothing but this forward packet, right? So forward packet means the first packet that I've added. So here 2590, right? This is going to this is the first packet that I have added, right? I have already removed this one, right? So we have to return 2590 and remove it from the router. So I have removed it from the router. This also done. And then add packet. So 5 to 110, we are going to add it, right? Then this again add packet 500 110, right? So 500 110, the only packet with destination 5 and timestamp in the this packet is added, return to 5 to 10, right? This we have added. Then this get count here, destination is 5, right? 100 to 110, so destination is 5, so packets with destination 5, right? So here if you see the only packet with destination 5 and timestamp in the inclusive range 100 to 100 inclusive, right? This one, this is nothing but destination, right? So we have to return 1, right? So here this is destination 5, so only one packet is there, right, with destination 5, right? That is nothing but this, right? And this one also, but 100 to 110 range, right? So that simply means this one 45105, right? So we have to return 1. That's it. So very easy, right? Example number 1, very easy, right? You are clear, right, what we are doing. So here these are the constants, right? And here if you see start time, end time 1 to 10 to the power 9, right? And at most 10 to the power 5 calls will be made to add packet, forward packet, and get count methods all together, right? If we made more than this, then we are going to get time limit exceed error, right? And queries for add packet will be made in increasing order of time step. This you already know, right? So here I can't do this one thing here. If you see, if I'm going to get the count, right? So from start time to end time, right? Can I search for all the packets, right? For with this destination, there can be this time step range. It can be very big, right? It can be very big, right? Start time to end time, it can be from 1 to 10 to the power 9, right? It can be very big. So definitely I can't solve this problem with O of n. So I have to think of better approach, right? So I can do one thing here. This if you see get count, and this 5 is nothing but destination. So first thing I can do here, with this destination 5, right, I will store all the packets, all the data packets that I have with this destination, right? Okay, this is the first thing. Now inside this also we can have many, right? Like we have to find 100 to 110, right? 100 to 110, right? Inside this also, so inside this also there can be very large, right? So what I'm going to do in this part, I'm just going to implement binary search so that I can solve this problem in of log n time complexity, right? Instead of checking all the data packets in the range 100 to 105 one by one, I will implement binary search. So binary search, all these values are increasing order of timestamp, right? So I will check now. I will, this is my low and this is high, and this is going to mid. So I will see if my packet exists here. So if it exists here, then I'm going to check in this range, right? Like this. If it is here, this is how binary search works, right? Then I have to check here, right? Like this. So I have to implement the binary search here, right? So now let's write the code first. What we have to do here? So when we are going to add packet, so data packets, we are, let's say we are adding data packets, right? So we have three things: source, destination, and timestamp. So in my code, what I'm going to do, let me maximize the screen. It's very simple, nothing complex here, right? So here what you need to do, first thing, here you can do one thing. This is your router, right? And here do one thing, create one class data packet, right? And in this data packet we have three things, right? Source, we have destination, we have timestamp. Three values we have, right? And now here I'm going to just create one constructor, data packet, and inside this I'm just going to pass, so my source, right? In the constructor I'm passing three values every time: destination, timestamp, right? And here I'm just going to initialize all this. So my source value, this source value is nothing but the value that I'm going to pass through my constructor s, right? So here I'm going to write s. Same way for destination I'm going to type d, and for timestamp I'm going to type T here, right? This is done. So I have created data packet, right? And this is nothing but a first in first out, right? So here what I'm going to do, I'm going to create one DQ, right? DQ, and in this DQ I'm going to add this data packet class, right? So here data packet, we have three values, right? Data packet, and here let's name it as Q. Done. And my router, in my router I'm giving what, limit, right? So here limit I'm creating, right? And here see, I have to check the duplicates as well. So can I store this 1490 as a string value in a one set? I can store it like this, one hashtag for hashtag 90 as one string, right? So here also I will get same string, so that simply means that it is a duplicate, right? So for this purpose I'm going to create one set. In set I'm going to pass one string, and let's name it as scene, right? For duplicates. After this I will also create one map, right? So I have to store, like, if you see get count 510. So for this destination, right, I have to find out the values in this timestamp range, right? So what I'm going to do, I'm going to create one key value pair, right? Key value pair. In key I'm going to add the destinations, all the destinations that I'm going to see, and for these destinations in the values I will just store the what is the timestamp for this, right? So once for this destination I have timestamps, so on these timestamps I can apply the binary search, right? That's what we have to do. So here I'm going to create map, and for key I'm going to say integer type, and here for timestamps I'm going to create one array list. Array list also consists of integer only, right? And here I'm going to write destination time stamps. Done. Clear, right? And here now in this router we are passing memory, so memory limit, right? So let's initialize all this. So here limit, okay, limit value is nothing but it is equal to this memory limit. Done. And here q, let's initialize this q as well, is equal to new linked list, right? And this scene set we have to initialize, so new hash set, right? And then the destination timestamps this value. So let me just copy this and paste it here, right? So this is nothing but a hash map, new hash map. That's it. So this is the basic structure, right? And this is my data packet. And also for if we are passing this this one, right, source, destination, and timestamp, so I have to return a key like this, right? So for this I'm going to write one method here, private string key, right, in this method. So we have to pass what, source, destination, timestamp. So from this what I'm going to return, I'm just going to return something like this, s plus here hashtag plus d plus hashtag plus d, right? So all these things, this is how I'm just going to return the key, right? Then it's very simple. Now we have to add the packet, so let's write the code for this. So first here let's generate the key. So string key is nothing but I'm going to call this key, and in this key I'm just going to pass source, destination, and timestamp, right? So here I'm going to write source, destination, and timestamp. Done. And once here I'm going to check if I can add packet or not. So first I have to check now if my scene dot contains, okay, if my set contains this key, then from here simply return false, right? If it contains, then we have to return false. Otherwise what we have to do, we have to check that if a limit is not already done, right? If we have already 3 packets and this is the 4th one, right? So we have to remove the older one, right? The first one that we have added. So here I'm going to check if q.site is equal to limit, then in that case we have to remove the oldest one, right? So here I'm going to write first data packet removed, and I will simply write q dot all first, right? So q is nothing but first in first out. So if I write this, this is the first data packet that I've added, so that is going to be removed, right? And here I'm going to check if removed is not equal to null, right? So here what I'm going to do, so in that case first here if I'm checking this, if you see q dot size if it is equal to limit, right? So the limit, can this value be 0? Can this value be 0 here? Memory limit, no, this value can never be 0, right? So here in that case I don't need to check this condition, if condition. Definitely I will get something value, right, from this remote, right? So here I'm going to write scene dot from this scene set. I'm going to remove what? I'm going to remove this key. Which key? The key that I'm going to get from this removed packet, data packet. So definitely here also from this data packet also I have three things: source, destination, timestamp, right? So here I'm just going to pass from this removed dot source, right, removed, right, whatever the packet data packet I removed. For this removed, what is the destination, and removed dot timestamp, right? All these things I'm passing. So from this key, right, key is nothing but method, right? I will get some key and I will remove it from my set, right? I have to remove it from set. And this is one thing I have to remove. Also I have to remove this same thing from my map, because my map is going to store the destination and the particular timestamp, so I have to remove that aspect. So here I'm going to write array list integer, right, and here timestamp list, right, and here I'm going to write destination timestamps dot get, right? From this just pass a removed key, right? For this key we are just going to get all the timestamps that we have. Destination, right? For this key we are going to get all the timestamps, right? And we have to remove the first one only, right? Because definitely we are going to remove the timestamp which we have added for very first time, right? And timestamp we are adding in increasing order, right? So here ts list dot remove 0, that's it. Remove oldest timestamp, right? Otherwise, if queue size is not equal to limit, then what you have to do, you have to create one data packet that you have to add, right? Data packet, let's say dp data packet new, and here you have to add data packet, and in this new data packet you have to pass all these values, right? Source, the destination, and the timestamp. So copy this and pass all these values here, right? So now you have to add this in the queue. So what you have to do, queue dot add last, right? So here you have to pass the values. So in the queue you have added, in the scene also you have to add this particular key, the key that you are already formed here, right? This key value. So scene dot add key value, and then once you do this, then also you have to pass the same thing, right? This destination in the map also, right? So for this one, just write it like this, destination timestamps, right? Your map name, destination timestamp, right? So here I'm going to write destination timestamps dot, just check if this particular key is there or not. Put if absent, which key? This destination key, right? So if key is absent, then you have to create one array list, right, for storing the all the timestamps for this particular destination, right? But if it is already there, then what you need to do, in this destination timestamps you have to just get that particular destination. You have to pass this key, right? You will get all the timestamps destination, right? You will get all the timestamps. In those timestamps you have to add one more timestamp, that's not what, this particular timestamp, right? That's it done. So we have to append it, and then we have to simply return true. That's it. Okay, now let's move to this forward bracket. So here forward bracket, so here first just check if your queue is empty, then you have to return empty array, right? So here queue is empty, then in that case you have to return new int 0, right? And then after that, once this is done, if queue is not empty, then you have to proceed further. So here data packet remove, right? Here just poll the first, right? Poll first means first inserted, right? So poll first, right? So this is what you need to do here. And once you poll this, so you have to remove this key also, scene dot remove, and here key method, in this key method you have to just pass the removed source, remove dot source, right? This remove object dot destination you have to pass, and then you have to pass the timestamp also, right? This is done. So this is what you need to do here. And then okay, then also you have to remove it from the TS list also, right? So same thing here you have to do. First here you have to call this, you can copy this, right? And here come here and paste this thing here. So array list TS list destination timestamps dot get this, you can pass remove rem, right? Rem dot destination, right? And here TS list dot remove, you have to remove this. And once you remove this, and then after that you have to return what? Return new int. And here inside this you have to pass this rem dot source, rem dot destination, and rem dot timestamp. This is what you need to return, right? So all these things you have to pass here. So this is done. So this is what you need to write in forward packet. So if queue is empty, then empty array. If it is not empty, then in that case you have to remove this, the first one, and once you remove it, you have to remove the key also, and you have to remove the timestamp list also from the map, right? So if you do this, right, and then what you need to do after that, you have to just return the remove one, source, destination, and timestamp. That's it, right? So now let's move to this get count. So in this get count, this is also very easy, nothing complex here. Okay, so here in this get count, first just check if this destination key itself is not there, then you have to return 0, right? So here destination, this destination, this is coming from which map, right? Destination timestamp map. So 1 second, copy this one, this part, right? So here I'm going to write if destination timestamps, right? If it doesn't contains the key, contains key, and here in this you have to pass what? You have to pass this destination. Okay, so if it doesn't contain this destination key, right, in that case you have to simply return 0. That's it, right? So this is done. Then after that, for this destination timestamp, right, destination key, you will get the list of timestamps, right? So just get that list first. So here what I'm going to do, in this line I'm writing array list of integer, and here ts timestamp list for this particular key, right? So destination timestamps dot get, and here I will pass destination as my key, right? Now from this I will take one lower bound, okay, and one left and right we have to find, right? And in the end what we have to do, we have to return math dot max of 0 and whatever the value we have, r minus l plus 1. Why I'm writing like this? So let's say 100 to 110 you have to find out, right? This is the range of timestamps, right? This is what you need to find. And let's say you have timestamps like this: 95, 99, 100, 105, 110, and 150, like this. So here if you see, these are valid, these three are valid, right? So if your L here, R here, so if I just give the indexing here, 0 index, 1 index, 2 index, 3 index, 4 index, so in total how many we have in this range, I can write it like this: r minus l plus 1. So r is nothing but 3, l is nothing but 1 plus 1, so that is nothing but 3. 3 is the right, so that is why I'm writing r minus l plus 1. So now thing is how I'm going to get this l and r, right? So this is also very simple. So here I'm going to call this lower bound method in this, and in this I'm just going to pass the list that we have, right? The list we have, and I'm just going to pass the start time, right? And same thing in R, I'm going to find the upper bound, right? Upper bound, and here I'm going to pass ts list, and here I'm going to pass end time, right? And here I have to subtract 1 from it. Now why I'm subtracting 1, that we will discuss now, right? So this is that, and here this is nothing but a return, right? So this is my method, right? So now I have to write the code for this lower bound and upper bound. So lower bound, in lower bound what we have to find out, we have to find out the first index which is greater than equal to target, right? First index which is greater than equal to target, right? So here 100 is the first index which is greater than equal to the target, right? We have to find in this range only, right? So this is the first thing, right? And so I can say this is my lower bound, right? And my upper bound is going to give me the first index which is greater than this 110, right? This one, right? So if I'm getting this one, then from this I have to subtract 1 so that I get R value, right? L is going to give me the first index, which is greater than equal to target, and my this upper bound is going to give me the index which is greater than the target. So this one, right? So from this, if I subtract 1, I will get this one, right? So that is why I'm writing -1 here. So for this one, first write the code for lower bound. Very simple, right? Simple binary search. We have used this code many times. So here private int lower bound, and in this I'm going to pass what array list of integer, and here list, and here target, right? So all these are my targets, right? First this target, this target, so this target, this target, this target. So first target which is in this range, right? So this is how I'm going to check. So here how we write is low is equal to 0, right? And high is nothing but list dot size, right? This is how we write. And once this is done, then we have to just simply run one while loop while my low is less than high. So here I'm going to find out the mid. So mid is nothing but how we calculate this, low plus high divided by 2, right? And then here I'm going to check if list dot get the element mid, right? If it is greater than equal to my target, right, then in that case my high is going to become the mid, and else my low is going to become the mid plus 1. That's it, right? And here we have to done nothing but low. That's it. So what I'm doing here, I have this list target, so low 0 and high is this dot size. So while my low is less than high, right? So while my low is here, high is here, and I will get some mid, right? So here let's say my mid is here, right? So now here if list dot get mid, the element at mid index, so at mid index, let's say here we have okay, so we have 105, right? So 105, let tell me this 105 if it is greater than equal to target, greater than equal to the target, right? The target, what is the target I'm passing? I'm passing as start time. Start time is nothing but 100. So yes, 105 is greater than 100. So that simply means that if this value is greater than 100, then there may be some value in the left side which is which can be greater than this 100. So I have to check in this range, right? So that is why here what I'm doing, I'm setting my high as mid. So my high I'm setting here, then again I'm going to check in this range, right? This is how it works, right? And then we have to turn low. So you can solve it like this, right? And same way for upper bound, you have to find out the first index which is greater than target. So it is going to be same here. Let me just copy it, paste it here. So this is nothing but upper bound, and here you have to write if list of mid is greater than target, first thing, right? This is what you need to find, right? That's it, and I don't see any other changes, right? So now let's run the code and see if there are any issues. We'll try to fix that. So yes, there are some issues, so let's fix them here. All right, line number 25. Let's see line number 25 here. So we have to return what here? We have to return s, right? So here this should be in double quotes now. This is like this, and d, then this should be like this only, right? Not a character, this is in double quotes. That's it. Now let's run the code and see if there are issues. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is happy, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.